last
video
lecture of the year.
Of
new material, non-review. It's been fun.
It has been. Until next time.
Till next time. Half-Life, last piece of this unit. These last two videos are really the unit, right?
And we're going to be predicting amounts of product of the daughter after Half-Lives have gone by.
Right. And a lot of this stuff is going to make logical sense.
Mhm.
Just follow the chart.
And so,
Right.
are all radioactive nuclides created equal, Mr. Mills?
Well, kind of, because they decay, but they don't decay at the same rate.
Or
So
by
that
the
makes it
same
different.
mode?
Or by the same mode. So that makes them a little
So-
different.
Different elements, different rate of decay.
Right.
Each radioactive isotope has a specific half-life length. Some are short, some are long. Even for the same element, the 6 different isotopes might have 6 different half-lives.
Absolutely. Actually, they will.
They have to.
They have to.
Some might be short, some might
Yep.
be long. But anyway,
Now, here's the key piece about this whole half-life thing. We're talking about the totality. So if I have 100 grams of this stuff, I know for sure when am I going to have 50 grams of the stuff. Right? But I cannot accurately predict which atom is going to decay next
Nope.
within that 100 grams.
Right.
It has nothing to do with which atom.
Right.
So it has something to do with the totality of them all.
100 post-it notes. I know that in 4.5 billion years, half of them will have gone away. I don't know which half, but I do know that half of them will be
And
gone.
that's a key point here. So, but it's just a point to know. Has nothing to do with how we fill out the chart.
So radioactive half-life. So there's a chart process. We always increase the half-lives each time we go down a row. So we go, literally when you get your chart, you go 0, 1, 2, 3, 4, 5.
Starting with zero is key.
Yes. Then when we do the other column, the time elapsed, we look up the half-life of the element. Maybe it's 5 years, 10 years, 20 years. And we start with 0, time elapsed. And then for one half-life, we put in that amount of time.
Right.
So
So if it's
2
12,
half-lives,
if it's 12 years, it's 12 years.
2 half-lives, 24. 3 half-lives, 36. So
We
you
are in
keep
unison even now.
adding on the
Yep.
amount of time from table N
There
that
you
it tells you.
There you go. And then we divide the starting mass by half each time there's a half-life, because a half-life tells me there'll be exactly half. So if I start at 100 grams on my 0 line, then I'm at 50. Half of 50 is 25. Half of 25 is 12 and a half grams.
Right.
And so those things are going to be very predictable.
Right.
And unless you get some crazy mass or crazy half-life,
Mhm.
you might not even need a calculator.
And then the last part, the fraction remaining, is important because that's often the testable vocabulary. What fraction remains after 3
Right.
half-lives? It's easy. You start with 1.
Half is half.
So 0 half-lives, 1 whole. And
Yep.
then 1 half-life half, 2 half-lives a quarter,
Yep.
3 half-lives an eighth, 4 half-lives a 16th, etc. You keep cutting your half in half.
Right. And what you're going to like about this, or what makes it easy about doing the chart, is those half-life numbers are set 0, 1, 2, 3, 4. And then the fractions
are set too.
At 0, or 1, 1/2, 1/4. Those will never change.
Nope.
You can almost pre-fill those in every time.
The
which
3
is nice.
columns in the middle will change, and sometimes you don't even need to deal with a column.
Right.
So let's check it out.
Let's check one out.
I'll step to the board here, Mr. Milks. Radioactive elements.
Okay, I see that it says I have a half-life of 2 days, so let's circle that bad boy. And it says what fraction, so that's what I'm looking for, would remain after 6 days. So let's start with our zeros. I got 0, 1, 2, 3, fill them in. And then we can go ahead and fill in our fractions, because those are a given. That's what's going to happen. And now time elapsed. At 0 is 0, but after 1 half-life is 2 days, right? And then 2 half-lives is going to be 4. And then 3 half-lives is going to be 2 more, is 6 days. And there we go. Boom, 6 days. What fraction remaining? We don't have to do anything with massive sample, because the problem didn't give us anything with massive sample.
Right.
So you see how we were able to figure out, using the chart, filling stuff in.
Because we were given the half-life in this scenario. Sometimes we'll have to figure it out.
Yeah, if they give us the element, we just have to look up the half-life in a periodic table. Well, not the
Cakewalk. Next one.
Uh-oh, lots of scribbles. So I have what a radioactive has a mass of 20 grams after 3 half-lives have passed. What was the original sample? So this one's going to go backwards with the mass. So let's fill out our half-lives. 0, 1, 2, 3. And it says at our 3rd half-life, we have 20 grams left. So it gives us the answer down there, right? So I know that if I went through a half-life and I ended up with 20 grams, I must have had 40 grams.
So you double it on your
Double
way
it
back.
going back up. So if I had a half-life there, no. If I had a half-life that left me with 40 grams,
Oh.
half of that, right? No, so it's
80.
80. And then 80, you got to double that going up. I started with 160 grams of my original sample.
Correct.
That would be right.
See how easy it is to get screwed up and just add 20. You've got to double backwards.
Yeah,
on
you're
your way
multiplying
through.
by 2 because a half-life halves the amount of sample.
Did we have to deal with any time?
It didn't ask us anything about that.
Nope. And we don't know what element it is to even look up our time because we're ignoring time elapsed in this particular example.
But it didn't give us anything for that, so we didn't need to do it. Okay. So now here I see I have a half-life of 10 years. It says how many total years have passed after the sample has gone to 1/4. So let's fill in what we know. We know 0, 1, 2, 3 is our half-lives. Fraction remaining is always going to be 1, 1/2, 1/4, and 1/6. And we know we're going to stop at 1/4.
Not 1/4, 1/8. Half of a quarter. is
Right,
an
but the problem asks us to stop at 1/4.
Right.
So we're good. And that's what we need to know. And it says it has a half-life of 10 years. So it goes 0, 10, and then 20, and then 30. And then look across from 1/4 and how much time it elapsed. We can infer that 1/4 is actually 2 half-lives because it's 1/2 times 1/2.
Yep.
And there we go. So the answer is 20.
20 years have gone by.
Very good. A little reading comp and a little bit of math.
All good.
All good. So radioactive element has a half-life of 5 years. How many half-lives have passed after the sample has decayed to 1/8? Okay, so now we're going to do the same thing we did in this last one. Fill in the first column, 0, 1, 2, 3 for my half-lives. Fill in my fraction right away, 1, 1/2, 1/4, 1/8. And look, 1/8, we got to go all the way to the bottom. And it says my half-life is 5 years, so it's going to go 0, 5, 10, 15. And now I see 1/8 and 15 years match up as far as what they're asking me in the problem.
Done.
We're done. It's really that simple.
Mm-hmm. Do we have another to do?
I hope so, but I don't think so. I think we only had the 4. Shall we see?
Let's find out. Oh, that's all, folks.
You guys got some practice and you're on your way.
That's it. We're done.
I got some kids that are ready to test out this week.
Good job, Milks.
Be well. Study hard.
See ya. I push a button and it's all done. I push a button, it's all